Flip-flops. So what are the flip-flops? It are the combination circuits. The logic circuit whose output at any instant of time depend only on the input signal present at the time are known as combinational circuit. There are two types of circuit: combinational circuit and sequential circuit. So if the output is depending on the input signal present at the time, then it is a combinational circuit. And if the output at any instant of time depends not only present input but also previous output, okay, then this type of circuit are known as sequential circuits. So basically we are working with this sequential circuit now. Combinational circuits are often faster than the sequential circuit. Why it is so? Because they don't have to wait for previous input to give output. Combinational circuit don't require memory elements, whereas sequential circuit requires memory device to perform their operations in sequence. Of course, they have to wait for the previous output, so there will be need of memory element to store the data. Sequential circuits are of two types: synchronous and asynchronous. Means if there is a clock applied to the circuit, then it is synchronous circuit, and if it's not clock applied, then it will not a synchronous circuit. Therefore, generally, asynchronous are considerably faster because they don't have to wait for the clock signal. Asynchronous circuits, a strong storage device is required to know that what happened in the past state. The basic unit of storage is known as flip-flop. So from here, the need of flip-flops arises. Why? Because it's asynchronous circuits are used as a storage device, and asynchronous circuits are used something lacking. So what is lacking? They are not waiting for the past state memory. So the basic unit of that to store that bit memory is called as flip-flop. The simplest kind of circuit is a memory cell that has only two states, either 0 or 1 bit. Such two state sequence circuits are called flip-flops because they flip from one state to another and then flops back to original. So it is originally the means of flip and flop. What is it? Does the mean of the word flip? They will flip from one state to another and then comes back to its original state. Flip-flop are also known as bi-state multiple regulator, latch or toggle. Block diagram is there are various inputs and two outputs, Q and Qn bar, 1 and 0, complementary of each other. Now first flip-flop is SR flip-flop. One set and one is reset input and two output, normal and inverted. Now first of all we use NOR based SR flip-flop. So two NOR circuit are there. There is output Q and Qn bar and two inputs set and reset. So what we have conditions for condition 0 0 0 1 1 0 and 1 1. So if let's take previous input is 1 and 0, 1 and 0. So from 1 you give it to 1 and S is 0. So 1 plus 0 bar equal to 1 bar equal to 0, means that comes back to its original states Qn. And here also is 0. So 0 plus 0, 0 bar equal to 1. So it will lead to no change condition. Means if 1 0 is here, it will give same result. But in this condition, set is 0 and reset is 1. Set is 0 and reset is 1. So suppose we have previous input element 0 and 1. So 0 will give here. Okay. So 0 plus 0, 1. It will lead to 1. Okay. And from here, 1 here. So 1 plus 1, 1 plus 1, 1, 1 bar 0 equal to 0. So what is doing? It is giving us 0 and 1. Means it's resetting back to its previous form. So if previous elements are 0 1 and if there is a condition of reset, that will give the same result as previous one. But if there is set 1 and reset 0, if set is 1, then what will give? It will give you same condition as previous one, 1 and 0. If both are 1, So if both conditions are 1, then it will not work, because in this condition it will give both on condition. So take 1 and 1, so both are 1, 1 and 1. So here 1, okay, suppose 0 and 1 we take R0 and S1 we take, suppose. So R0 S1, here 1, so 1 plus 1, 1 ka 0, and R0 and here this is 1, so 1 plus 0 1, 1 bar 0, so both are giving 0. So it's a forbidden condition. Flip-flops, SR flip-flop can't work in this condition. Okay, so just remember this equation. If both S and R 0, then same result as previous one. If reset is 1, set is 0, so it will reset means it will give original value 0 and 1 what is previously stored. If set is 1 and R is 0, then it will give you Q1 and Qn bar 0. Now we have SR latch here. Same. Suppose both have 1 and 0. Previous input is 1 and 0, and set condition is equal to 1 and R equal to 0. So here 1, so it will come to 1, 1 plus 1, 1 bar equal to 0. It will give you 0. And if you here are 0, so 0 plus 0, 0 bar equal to 1. So it will give same result as, it is not giving the same result but opposite to the what is stored in previous one. Okay, so set 1, so set 1, then Qn equal to Qn plus 1 equal to 1 reset, and Qn plus 1 bar equal to 0. And this was the condition I discussed. If both are 1, so it's a forbidden condition and it is not possible. And if 1 and 0 is here, then what will you do? You will again repeat the same process. So just you have to remember this truth table means both are 0, then no change will be there. If reset is 1, then it will reset the flip flop, means it will give you again 0 in the Qn. So obviously Qn by equal to 1. If set is 1 and reset is 0, set is 1 means it will not be able to reset. It will not be able to give the same condition as set, and Qn bar will be 0. And 1 1 is forbidden because it is giving you both 0. Now we can make SR flip-flop based on NAND gate. So simply NAND gate same Q and Q bar. So S bar and R is here. Again same condition will be there. If both are 0, then no change. If reset is 1, then it will be reset, means it will Qn will be resetted to 0. And if set is 1, then it will not be able to reset, means it will be set, means Qn 1, and 1 1 is forbidden condition. Now state diagram. What is state diagram? If we start from 0, then it will be reset, means R is 1 and S in 0, so it will again lead to 0. R is 1 and S is 0, so it will again lead to 0. Okay, and what is the condition for set? Set is S is 1 and R is 0, S is 1 and R is 0, so it again lead to 1. Okay. And from 0, if set lead to 1 and reset 1 to 0. Now present state next level truth table. So suppose present state is 4041. So what will we have? 01010101 00110011 2 raised to the power 3, means total 8 states are possible. Okay, so both are 0, then no change. If reset is 1, then it will lead to reset. Reset means it will lead to 0. If set is 1 and both are 0, then it will convert 0 to 1. Period state will be converted to 1. If both are 1, then we know it's a forbidden state. and if both are 0, we know this then no change will be there, so Qn will be Qn. If again reset is 1, reset of Qn will be to 0. If set is 1, then it will convert it to 1, and both are 1, then don't care state, we will not care about this state, it will not be solvable. So it's a K-map for this. We know what is K-map. So 0, 1, 2, 3, 4, 5, 6, 7. So 1 is coming in 1, and 1 is coming 1, 3 and 5. 1, 3 and 5. So 1, 3 and 5. Sorry, this one Qn plus 1. Next stage, it is the reset state. Next stage is 1 is in 2, 4 and 6. So 2, 4 and 6, and obviously it will be don't care state, will not be bother of this. So there will be two couple possible, this one and this one. So what is the common between these two? First of all, B. B means R. B means R bar, है ना, this one, and here will lead to 0. So R bar, because say sum of products. Okay, now among these two, here also 1, here also 1, means S is common, and here Qn will be common in this stage 2 and this stage and this stage. So it will lead to this K-map, S plus Qn into R bar. Just remember. Now types of flip-flops. There are two types of flip-flops. Clocked. First of all, if clock is 0, then we care off. Clock is 1, then we call on. So S and S bar, we give a clock signal to this. So 4 NAND based clock flip-flop we have made SR flip-flops NAND based. Now we will need 4 NAND gates to make synchronous clock plus SR flip-flop, and similarly for NOR based. Now just remember this, how many NAND gates will be required to make SR flip-flop based on clocked, means synchronous. So we will need 4 NAND gate. Now we will discuss about D flip-flop. Just you have thorough memory of these things, then only you will be able to solve the questions MCQ in your examination. 4 questions will be there, 150 question, 3 hours. So there will not be any major calculation there. There will be memory based and simple calculations will be there. So you don't have to attempt all these 150 questions. You will have to attempt minimum question so that you can ensure your selection in that examination. So it is possible if you remember the more things. Okay. Now D flip-flop. So D means P here, input is 1 and delay input is P. Delay input can be 0 or 1. So just what we are doing, same, but we are introducing a clock in our circuit, logic circuit. So here we can say this is S, this is R, it is delay input. So if 0 is here, then 1 will be here. If 1 will be here, 0 will be. So when clock is off, then circuit will not work, no input, no output. But when clock is on, then we have two input, 1 and 0. Suppose D is 0, so D is 0, then R will be 1 and S will be 0. So it will be reset condition. Reset condition will give you the same result as, so it will reset the flip-flop to 0. When again it's 1, if the input is 1, then S is 1 and R equal to 0. It will be set condition. Set condition means input will be given to, output will be given to 1. So the D flip-flop are used as delay device. Okay, so these are basically the delay device which can hold a bit of binary how much it can store. It can only store a bit of binary information, okay, not more than that. Now KMap present registers are 0011, so delay input can be 0101. So if delay input is 0, then next is 0. If delay input is 1, then 1, then 1. If delay input is 1, so same condition as we discussed here. So characteristic equation of D flip flop, it will also should be remembered. D flip flop condition Qn plus 1 equal to D, and this is the KMap. Now toggle flip flop, same as delay flip flop, but here is a toggle input, so it is also a JK flip flop. So here the word toggle means toggle will invert only when T is high. So when T is high means this condition, then only the previous input will be inverted, 0 to 1 and 1 to 0. But there is a condition, the clock must be on. If the clock is off, then there is no change. If clock is off and toggle is high, then will also no change. And sorry, present input is 0 and clock is on, then will be there. But if present input is 1 and clock is on, then it will not be able to change the output. Well, it not able to invert the output. But if present input there and clock is on, then only it will give you, toggle is on, then only it will give you inverted of the previous state. So here is the toggle circuit's characteristic equation, Qn plus equal to T, Qn bar plus Qn into T bar. Basically the over operation of it is the product of sum. Now JK flip flop. So JK flip flop has a characteristic similar to SR flip flop. Input JK behaves like input S and R to set and reset the flip flop. When both are one inputs, flip flop output toggle, that is, it switches to its complement state. Remember this, very important. When both are one, then it will switch to its complement state. A JK flip flop can be constructed using SR flip flop by the addition of two AND gates. So it is a SR flip flop. Now just have a look. If clock is not on, then there will be no change in the circuit. When clock is on, but J and K are 0. When clock is 1, so he will be 1, but J is 0 and K is also 0. J is 0 and K 0 means from here 1 0 0 1 0 0, so 8 and R both are 0. So when S and both are 0, then will be no change. We have studied it in SR flip flop. When clock is on, when clock is 1 and J is 0 and K is 1. When clock is on and J is 0 and K is 1. So J is 0, white state, and K is 1. So suppose we have previous state 1 and 0. Okay, so first check this. Clock is 1 and this is 0. So 1 0 will be 0. Clock is 1 and this is 1. That will give you 1. So here is 0 and here is 1. Okay. And what is the state here? Suppose we have previous state 1 and 0. What is previous state here? 1 and 0. So 1 from here and 0 from here. So again it will lead to 0, it will lead to 1, because 1.00 and 1.1 equal to 1. So now we have S is 0 and R is 1, white, concentrate on the white part. Okay, so S is 0 and R is 1, means it is the resetting condition. In resetting condition, what will happen? Qn will be 0 and Qn bar equal to 1. So it will give you toggling the previous result, 1 to 0 and 0 to 1. Okay, now suppose we have J is 1 and K is 0. J is 1 and K is 0. this one condition. Suppose we have qn equal to 1, previous input is 0 and 1. So from 0 it will go here, so 0 will be here, and 1 is from here, 1 is here. Okay, so 0 is here and 1 is here. Now suppose j is 1 and k is 1, j and k both are 1. So j and k both are 1. What will happen in this condition? Check it. J is 1 and k is 1. So 1 1 1 1 0 0. Okay, 1 1 1 and 1 0 0. So it will s equal to 1 and r equal to 0. It's the set condition. So in set condition out will be qn. In set condition out will be qn equal to 1, qn bar equal to 0. Okay, here also set condition, and when both are 1, j, k and clock is 1, both are 1. So what will happen? 1 1 1 1 1 1, both are 1, both are 1 condition. In the toggle condition we have studied this. So it will lead to qn bar condition. So thus you can remember this truth table. Now it is very important to realize here that because of feedback connection in J and K flip-flop, a clock pulse that remains in the one state while both J and K are equal to 1 will cause the output to complement again. When clock is 1, J and K is 1, then it will toggle, when output will be complement again and again until the clock pulse again go back to 0. So till the time when clock again doesn't go back to 0, it will toggle the input. So to avoid this undesirable state, the clock pulse must have time duration that is shorter than the propagation delay time of the flip-flops. Now this is the restrictive requirement that this problem can be solved either using a master flip-flop, master slave flip-flop, or using a age triggering clock construction instead of level triggering. Now state diagram is 1 to 1, 0 to 0, and 1 to 0 in J, and K is 1 to 0. So J qn bar, qn k bar. Now we will use master slave flip-flop. The race round condition. Let's discuss it. What is the race round condition? Because of the feedback connection or at input J and K, the input will change many times during a clock pulse. That's what was happening here. Hence output will oscillate between 1 and 0. This oscillate between 1 and 0, toggling in the duration of clock pulse width. Due to whenever clock pulse is high, then it will toggle and make complement of the original input preset state, due to which at the end of clock pulse the value of q is ambiguous, which means uncertain. This is known as race round condition. The race round condition can be avoided if width of the clock pulse, that is TP, is less than propagation delay of J and K flip-flop. It will be equal to 2 AND gate, because 2 NAND gates, because we were using 2 NAND gates. The race round condition can be avoided or we can use master slave flip-flop. So it will not be feasible for us to use master slave flip-flop. So this is master slave flip-flop. So the first flip-flop is known as master and driven by the positive edge of the clock pulse, and the second flip-flop is known as the slave and it is driven by the negative edge of the clock pulse. Therefore master responds to the positive edge, but slave responds to the negative edge of the clock pulse. So it will work in positive, it will be negative edge of the clock pulse from here to here and from here to here. Look at the circuit. Again same truth table, 0 1, and you can have an idea. You don't have to remember this, you just have to solve the question. So we will do numericals, then we have a clear idea about this. Now when a clock is positive, master process and give outputs. During this slave has a buffer between master and output. So whenever clock is positive, the master will be take in charge and will be give outputs and till this time slave will be act like buffer. Now when a clock goes negative, master will behaves like buffer and slave will give you output. Now what are the apps? So this is the clock pulse. So when clock are high, j and 1, this will be condition. When this is high, what will happen? Master will perform till here. Then clock is low will be slave will perform, will output, and this will be so goes on. So it will act like frequency division. Means frequency division, it will divide frequency to half for 1. So if we want to, a frequency division of 2 raised to the power n is achieved by connecting n flip-flops. So when you have n flip-flops, then frequency will be divided from the clock pulse input will be 1 upon 2 raised to the power n. Just remember, very important. Now parallel data storage, it also can be used as 1 bit, है ना? Row of zeros and are called registers to shift data, and it is a counter. Thank you very much.